welcome back to Financial Management course. For today, we will learn about time value of money. After studying Chapter 3, Part 1, you should be able to understand what is meant by the time value of money, understand the relationship between present and future value, describe how the interest rate can be used to adjust the value of cash flow, both forward and backward to a single point in time, calculate both the future and present value of an amount invested today, a stream of equal cash flows or an annuity, and a stream of mixed cash flows. And all the material is come from the book Fundamentals of Financial Management by Van Horn. Okay. Time value of money is a central concept in financial management. So why is time value of money important? There are at least two reasons why this is so. First of all, the risk of future income is higher than current income. And the second, there is the opportunity cost of future income. Okay, for the time value of money, we will learn about the interest rate, simple interest, compound interest, amortizing alone, but this one is for part 2, compounding more than once per year. It's also for part 2. Okay, now we learn about the interest rate concept. Which would you prefer? 10,000 today or $10,000 in 5 years? Yeah, common sense tells us to take the $10,000 today because we recognize that there is a time value of money. So that you already recognize that there is time value to money. The immediate receipt of $10,000 today provides us with the opportunity to put our money to work and earn interest. So why time? Why is time such an important element in your decision? Yeah, because time allows you the opportunity to postpone consumption and earn interest. Okay, there are some types of interest. There is simple interest. Simple interest is interest paid or earned on only the original amount or principal borrowed on lent. And then the second one is compound interest. So for the compound interest is interest paid or earned on any previous interest earned as well as on the principal borrowed on lent. This is the simple interest formula. Simple interest equal P null. P null is principal or deposit today or original amount borrowed at time period 0. E is for interest rate per time period and is number of time periods. So the formula is simple interest equal P multiple E multiple N. So this is simple formula, simple interest formula. So this is simple interest example. Assume that you deposit $1,000 in an account earning 7% simple interest for 2 years. What is the accumulated interest at the end of the second year? Okay, for the solution, we use the formula simple interest equal P0 multiple interest multiple n or number of time periods. So use this formula. P0 is $1,000 for interest is here 7% or 0.07, and for the number of time period is 2 years, so you can put 2 here. You can use calculator here, and the final result is $140. This is the solution. So what is the accumulated interest at the end of the second year is $140. Okay, now what is the future value of the deposit? Yeah, this is simple interest for future value. What is the difference? This one is accumulated interest and this one is future value. So for the future value is P0 plus simple interest. The P0 is 1,000 here plus simple interest is 140. So the future value of the deposit is $1,140. Yeah. Okay, is it clear enough? Yes, I think so. Now you can continue. Now, future value is the value at some future time of a present amount of money or a series of payments evaluated at a given interest rate. And how about the present value? Yeah, this one is for future value. For present value of the previous problem is the same problem. Yeah, here, this one. How about the present value for this problem? The present value is simply the 1,000 you originally deposited. That is the value today. So the present value is the value today. The answer is $1,000 here, or P0. Yeah. This is present value. So the present value is the current value of a future amount of money or a series of payments evaluated at a given interest rate. Why compound interest? This is future value of a single 1,000 deposit. The yellow one is 10% simple interest here. The start is the same, but the final result for compound interest, 10% compound interest is much higher than simple interest. This is same 10%, but the final result for compound interest is much higher. Usually in a bank, use compound interest, so the money is become the interest is become high and higher. Okay, this one is future value, single deposit, with graph. Assume that you deposit $1,000 at a compound interest rate of 7% for 2 years. This is 7%, $1,000, start $1,000 for 2 years. Here. This one is future value. Okay. Okay. Assume that you deposit $1,000 at a compound interest rate of 7% for 2 years. Okay, future value single deposit formula. Future value 1 and 1 equal P null. This one is in 1 plus E, 1 plus E to the power of 1. 1 is from here. If the year is 2, this one is to the power of 2. P null is 1,000. 1 plus A interest is 7% or 0.07. So this one is 1 plus 0.07 equal 1.07. 1,000 multiple 1 0.7 is $1,070. So for future value in year 1, single deposit, compound interest, you earn $70 interest on your $1,000 deposit over the first year. This is the same amount of interest you would earn under simple interest. If just 1 year or in the first year. But how about the second year? Please look at this one. This is year 1, this is year 2. For year 1 is P null multiple 1 plus interest to the power of 1. The result is $1,070. For future value, year 2 is future value year 1, multiple 1 plus interest one, or P null plus 1 plus interest, multiple 1 plus interest. You know that future value, the formula is this one, and you put here P null plus 1, like this. So the result, the final result, this formula. P null multiple 1 plus E to the power of 2. Here. So the result here, $1,000 multiple 1.07 to the power of 2. So the result is $1,144.90. So you earn an extra $74.90 in year 2 with compound over simple interest. Yeah. So that's why for compound interest is much higher. Okay, this one is general future value formula so that you can remember. Future value 1, year 1 is P0, multiple 1 plus E to the power of 1. Future value 2 is P0, multiple 1 plus interest to the power of 2. So you can see here that general future value formula, yeah, future value n equal P0 multiple 1 plus E to the power of n here. Yeah. Or for if you use the table, yeah, future value n equal P0 future value interest factor E n, yeah, see table. Okay, wait a minute. Okay, how about the valuation using table? Yeah, and this one is table 1. Table E, yeah. Future value interest factor En is found on table. You can see that period, this one is for N, and this one is for E. Yeah, table interest, this one is N, and table, and this one is interest. This one is interest. So if the year period is 2 years here, and the interest is 6%, so the future value interest factor is here 1.124. And if the period is 2 years and the interest rate is 7%, so the FVIF is 1.145. So yeah, you can put here P0, yeah, multiple FVIF. Wait a minute, there is a trouble here. It should be smaller. Okay. Yeah, here. Future value 2 is 1000. This is the example of the solution. 1000 or P0 multiple FVIF 7%. Year 2 is here 7%. Is year 2 is 1.145. So 1000 multiple 1.145 is 1145. Why it's a little bit different with this one is 100. This one 101.44.90. It's due to rounding, ya, pembulatan. Actually the same, yeah. The results should be the same between here with using value table. This is using value table, and this one is using formula. Almost the same. The difference is due to rounding. Okay, then value of money on the calculator. I will skip this one, but the result will be the same. Okay, now we move to story problem example. Yeah, Julie Miller wants to know how large her deposit of $10,000 today will become at a compound annual interest rate of 10% for 5 years. So N is 5 years and the interest is 10% and the P0 is $10,000. So calculation based on general formula, future value N equals P0 1 plus A to the power of N. Yeah. So future value 5 is $10,000. Multiple 1 plus 0.10 to the power of 5. So the result is $16,105.10. This is the calculation based on the table I. Yeah. So if we have 10% 5, the result is 1.611. So the final result is 16,110. Due to rounding, actually almost the same. It's due to rounding. And the result using the calculator should be the same. Okay, double your money, quick. How long does it take to double $5,000 at a compound rate of 12% per year approximately? We will use the rule of 72. How? This is the way to use the rule of 72. So 72 per 12% is approximately 6 years. Yeah, if you use calculator, the actual time is 6.12 years. Yeah, this is the calculator. Okay, present value single deposit. Yeah, using graphic. Assume that you need $1,000 in 2 years. Let's examine the process to determine how much you need to deposit today at a discount rate of 7% compounded annually. So it means that you need $1,000 in 2 years. Yeah. Year 1, this one, year 2. Now, how much you need to deposit today? So, yeah, this one. Present value 0 at a discount rate of 7% compounded annually. This one, present value single deposit formula. Present value equals future value per 1 plus E, yeah, to the power of 2, yeah. So this one is $1,000 per 0.07 to the power of 2. So the result is 873.44. So you need to deposit today, yeah, 873.44 to get 1,000 in 2 years. This one. So in 2 years you will get 1,000 using a discount rate of 7% compounded annually. Okay, this one is general present value formula. You can use this one. Present value 0 is future value 1 per 1 plus I to the power of 1. If this one 2 is to the power of 2, etc. etc. So the formula is here, the general formula is here. This one, present value 0 equal future value n per 1 plus interest to the power of n. Yeah. Or you can also use table 2. Yeah. Present value 0 equal future value n multiple present value interest factor interest n. Yeah. Okay, this is valuation using table 2, yeah, present value interest factor interest and n, yeah, is found on table 2, and for period interest, yeah, I for interest, yeah. You can see here this one, for example, the period is 2 years and the interest is 7%, so the result of PFIF is 0.873. Yeah, if we use using present value tables, so PV2, yeah, the result is here, $873. Yeah, it's almost the same. The difference is due to rounding here. Yeah, almost the same with this one. Yeah, yeah, almost the same with this one. If we use formula here and the use of value tables here. This is if the use of calculator, but I will skip this. Okay, story problem example, the next. Julie Miller wants to know how large of a deposit to make so that the money will grow to $10,000 in 5 years at a discount rate of 10%. So now interest rate is 10% and the money for the money will grow to be $10,000 in 5 years. Yeah, so how much for the present value of money today? So how large of a deposit to make $10,000 in 5 years? So calculation based on general formula is here. Present value 0 equal future value per 1 plus interest to the power of n. So this one is future value, it's $10,000. This one is 1 plus 10% or 0.10 and n, yeah, to the power of 5. So the result is 6,000 and $6,209.21. So the present value is $6,209.21. So the calculation based on table is almost the same. The final result is 9,210. Yeah, this is almost the same. The difference is due to rounding. If we use calculator, the result is almost the same as well. So that's all about time value of money. In part 1, we learn about present value and future value. Okay, thank you very much for watching. See you.